Ever wondered how massive commercial airplanes can touch down safely even when pilots can barely see the runway or can't see it at all? Today on Knowledge Hub, we're breaking down how airplanes land themselves in zero visibility, using a carefully layered system of ground-based guidance, onboard computers, and extreme redundancy. It all begins with the Instrument Landing System, or ILS, installed at major airports, where a localizer antenna beside the runway transmits radio beams that guide the aircraft left and right with meter-level precision, while a glide slope antenna near the runway threshold sends a vertical guidance signal that defines the exact descent path, typically around 3 degrees. Inside the aircraft, multiple radio receivers continuously track these signals and feed them into the flight control computers, where the autopilot compares ILS data with inertial reference systems, GPS position, airspeed, and attitude sensors to build a highly accurate picture of where the aircraft is in three-dimensional space. In low-visibility operations, especially Cat 2 and Cat 3 approaches, this automation becomes critical, because visibility can drop below 75 meters, far less than the length of the aircraft itself. To handle this, certified aircraft engage multiple autopilots simultaneously, often 3 independent systems running in parallel, each with its own sensors, power supply, and logic, constantly cross-checking results and voting out any system that disagrees. As the aircraft descends through dense fog, radar altimeters take over, from barometric altitude measuring height above the runway surface with centimeter-level accuracy, allowing the flight computer to time the flare maneuver perfectly, gently raising the nose to reduce vertical speed just before touchdown. At the same time, the autothrottle system precisely controls engine thrust, compensating for wind gusts, turbulence, and ground effect, then smoothly retarding power to idle at the exact moment calculated by the flight computer. During the final seconds, the system transitions into rollout mode, where lateral guidance continues after touchdown, using rudder, differential braking, and nose wheel steering to keep the aircraft centered on the runway, even if the pilots still can't see the runway edges. Throughout the entire process, pilots are actively monitoring dozens of parameters, listening to automated callouts, verifying system modes, and staying ready to instantly disconnect automation if anything falls outside strict certification limits. So the next time you're sitting on a plane descending into thick fog and can't see anything outside the window, remember, it's not a single piece of automation doing the job, but a carefully layered system of ground-based radio signals, redundant flight computers, precision sensors, and constant human oversight, all working together to guide that aircraft safely onto the runway. If you enjoy breaking down complex systems like this and want more deep dives into the hidden technology behind everyday life, make sure you subscribe to Knowledge Hub for more fascinating explanations. And as always, stay curious.